Good morning, everyone. First of all, I would like to introduce myself. My name is Andrew Rai. My roll number is 20NSO311 from Namchi Government College, affiliated with Sikkim University. And my presentation topic is X-ray spectrometer on XPS technique and XRF technique. And also, I would like to acknowledge, first of all, I would like to express my special thanks to gratitude to Dr. C.P. Khadiwala sir for giving us this wonderful opportunity to us to learn more about new things on XPS technique and XRF techniques. And I also want to thank my family and friends who support me financially and with all this setup to finish my projects. Thanks a lot to everyone. So let's start the XPS and XRF technique. We are going to see XPS technique first and then XRF technique. So XPS technique, uh, it is stand for X-ray photoelectron spectroscopy. X-ray photoelectron spectroscopy is a comprehensive technique for analyzing the surface layers of semiconductors, metals, plastics, and fibers. The method is used for determining the elemental compositions of the surface, the chemical states of the element, as well as the electronic structure of compounds. The history of XPS: in 1887, Heinrich Hertz observed UV-irradiated electrodes emitting more sparks, and Albert Einstein received the Nobel Prize in Physics for explaining the photoelectric effect. And because the photoelectric effect is the basic principle of XPS technique. And another, whilst waiting for the path to do something completely different, Kai Ban used his ultra-high vacuum spectrometer to observe photoelectrons generated by X-rays. He received a Nobel Prize for this in 1981. He called the newly developed technique electron spectroscopy for chemical analysis, which stands for ESCA. That time, the stainless steel modular ultra-high vacuum systems were developed. Manufacturers made monochromatic systems. Peaks were printed into graph papers, and their positions and intensities measures manually with rulers, scissors, and weighing scales. In the early 1980s, computers started to make data collection easier. VMS data format was invented so all data could be compared. Um, Casa XPS developed in 1999. Other data processing software is available. After that, we started having to be clever about interpreting the spectra. Over the last 20 years, the internet has provided radically accessible information which has improved interpretations. Basic principle of XPS. So, basic principle of XPS. Why is this technique surface? So the excited photoelectrons are relatively slow and most interacted with the material they are generated and lose energy. Few electrons get out unscattered and are detected as the photoelectron speaks, mostly from the upper 10 nanometer of materials. So basic principle of experience in to start with, X-ray excite electrons from a material surface. Then all elements except H can be ejected. The electron energy depends on the element. The electrons orbit binding energies. Then we have to calculate atomic percentage and calculate the layer thickness. And small shifts in the binding energy are caused by bonding to different atoms. So the oxidant state of the atoms can sometimes be determined from the shifts. Now the application. XPS can be used to analyze the surface chemistry of a material after an applied treatment such as fracturing, cutting or scraping, from non-stick cookware coatings to thin film electronics and bioactive surfaces. XPS is the standard tool for surface material characterizations. Now we are going to see another technique, that is XRF technique. Now we are going to see XRF technique. First of all, what is XRF technique? XRF technique, X-ray fluorescence spectrometry, is an elemental analysis technique with a broad applications in science and industry. XRF is routinely used for simultaneous determinations of elemental compositions and film thickness. Modern XRF instruments are capable of analyzing solids, liquids, and thin film samples for both major and precious ppm level components. The analysis is rapid and usually sample preparation is minimal or not required at all. XRF is based on the principle that its individual atoms, when excited by an internal energy source, emit X-ray photons of characteristic energy or wavelength. By counting the number of photons of each energy emitted from a sample, the elements present may be identified and quantified. The theory: when an electron beam of high energy strikes a material, one of the results of interaction is the emission of the photon, which have a broad continuum of energies. This radiation, called Bragg radiation, is the result of the declarations of the electron inside the material. The Brem's long continuum is illustrated as a function of electron acceleration voltage for a molybdenum target. Most of the XRF instruments in use today fall into two categories: energy dispersive (ED) and wavelength dispersive (WD) spectrometers. Within the two categories is a tremendous variety of differing configurations, X-ray sources, optics, and detector technologies. WD spectrometers, what are they? They are the instrument operators based on the principle of a Bragg diffraction of a collimated X-ray beam. In this case, the beam emanating from the sample or detector is angularly scanned relative to the analyzed crystal, registering the spectrum. And another one is energy dispersed ED. What are they? They are the entire polychromatic spectrum from sample is incident upon a detector that is capable of registering the energy of which photon that strikes it. The detector electronics and the data systems then build the X-ray spectrum as a histogram with the number of counts versus energy. Here we can see X-ray, that is specimen. Specimen emits characters X-ray or XRF. Analyzing a crystal rotates accurately reflect each wavelength and satisfy a Bragg's law and lambda d2 sin theta, which is a Bragg's law equations. Detector measures of positions and intensity of XRF peaks, and XRF is diffracted by a crystal at a different theta to a separate X-ray L to identify elements. And this is how the patterns looks. So advantage of XRF. XRF is a versatile, rapid technique. It is a non-destructive method of chemical analysis, important as in a case of samples in limited amounts or valuable or replaceable. It is precise with a skilled operation. It is accurate, applicable to a wide variety of samples from powders to liquids. It is convenient and economical to use, with the major input cost being the hardware itself, which average around $75,000 for modern industrial use spectrometers or $125,000 for research quality instrument. The instruments have a few moving parts, tends to be a low maintenance, and on a regular basis consume only liquid nitrogen and electricity. So basically, the advantage of XRF is also a future scope for it. And disadvantages include the fairly high limits of detections, which compared to the other methods, possibility of metric effects, although these can usually be accounted for using software-based corrections procedures, loads for graphite, furnace automatic observations, spectroscopy, beat XRF by several orders of magnitude, but analysis can exhibit substantial matrix effect. GFAAS is also relatively slow, with one element determined at a time and is destructive. PXRF instruments are capable of producing result comparable in many ways to a lab-based XRF at a fraction of cost. PXRF instrument can be purchased for about $30,000 to $50,000, complete with a vacuum systems, sample charge changer, and accompanying the computer. Application of XRF technique. It is a method of elemental, metal and non-metal analysis with atomic number greater than 12. Quantitative analysis can be carried out by measuring the intensity of fluorescence and wavelength characteristics of a element, being determined especially applicable to most of the elements in the periodic table. and it is also used in a medicines area. In a medicine area, the direct determination of a sulfur in protein, the sulfur content of each of the many different forms in which protein exists in human body varies considerably. XRF indicates protein distributions, provides a diagnostic link for a medical practitioner, determination of a chloride in a blood serum, determination of strontium in a blood serum and a bone tissue, elemental analysis of tissues, bones, and body fluid also can be applications of XRF. And it is also used for determination of trace elements in plants and foods. And also further, it is used for detection of pesticides on foods and herbal drugs. It is also applicable in a scheme. So now we know the XPS and XRF techniques. So if you ask me what is the difference between XPS and XRF technique, all of these three methods utilize X-rays. Two methods utilize X-ray in a different ways, which is why different kinds of informations can be obtained from the sample with each one of them. In XPS, the atoms of the sample surface absorb X-rays and emit electrons, but in XRF, the atoms of a sample both absorb and emit X-rays. When the emitted X-rays are analyzed in XRF, the elements present in the whole sample can be identified and their concentration determined. The same information can be obtained. So lastly, I would like to conclude my presentation by saying that the future scope in XPS and XRF can be used for a variety of analysis for environment, including geology, soil surveys, or field analysis. Due to the versatility of XRF, it can be used to examine everything from sewage sludge, car exhaust, river water, and so much more. So the future scope is much more than we think. Thank you. Thank you.